My channel. Copy. Let me open this down here. Close that. And all right. Okay, we're gonna get started. So we're back at this. I'm just to give a quick overview of the project. This is called Parasitic C. It's a compiler I'm trying to write. And right now, all it is going to do is parse a subset of C, turn it into an abstract syntax tree, so, parsing, and then print out the syntax tree as C code again into a file, and then I'll be able to call a C compiler on that and run the C program as an executable. And the reason we're doing this is because I want to be able to compile the compiler itself with itself. So I want to get to a bootstrapping compiler very quickly, and I think this is maybe the best way to do it, or at least a new way to do it that I've never tried before. So that's the point. I'm trying to keep the C that I do use relatively simple so that it's easy to parse and compile. And so that's sort of a constraint we have right now. And once we have like the self-hosted bootstrapping compiler, then I can begin to add interesting features to C and mutate it into a new language. So it's called Parasitic C because it's going to eat C from the inside out in a way, kind of like Parasite. So, okay, so off camera, I did a little bit of work just setting up, testing out some parsing stuff. So I will talk about this in a bit and show you what I've got done with that. But this is in this file over here. But in sort of thinking about this a little bit, I decided to add a couple more features that I'm allowed to use. So I'm allowed to use arrays, static arrays up here. And I decided I should be allowed to use enums and unions and nested structs because that's just going to make implementing this a whole lot easier, and I don't think it's going to make I think the benefits of the ease of implementation outweigh the cons of added complexity to the compiler. I think this won't add that much complexity. Over here, I have been sort of avoiding using enums and like maintaining this really obnoxious list of hand maintained numbers. So the first thing I'm going to do is just make an enum for all this stuff. I want to clean up this code a little bit inside of the lexer. So this is going to be, I'm going to call it a token. And just going to throw all this stuff in here and indent it. I'm going to delete all of these ints. Okay, I need commas at the ends of these. So we will do this. I'm sure there's some clever Vim way of doing this, but I'm just going to do this because I don't want to think about my editor that much. All right, and I am noticing I'm missing a couple of these. I'm just using the mouse and hitting dot to repeat the action I did first, which was delete until the end of the line and replace it with comma. But we're almost done, so. Bam. Bam. Okay. Now I just need to go and delete a couple of these spaces that I missed. I mean, it's not a huge deal. Actually, I can just auto format. All right. Cool. So now we have an enum called token. And this needs to be ended with a semicolon. Does that leave any errors? I actually don't think that leaves me with any errors. I don't need these comments anymore because we can clearly see where the enum begins and ends. Oh, this should be here. And now I can actually reorder these if I want. So I was feeling like this is really more like a literal anyway, angle bracket file name. So that's the name for this type of token where it has angle brackets and a file name in there. So, because it's very similar to a literal string. Okay, and I think what I'd like to do is anywhere that I am pretending to return an int, like out token type, I feel like I should go back and say enum token. Should this be called like token tag, like toke tag? Yeah, let's do it like that. I don't really want to use type defs. I'd rather just say enum toke tag. So we're just going to do, I don't know, maybe I should just leave it as int. All right, we'll leave it as int. So anywhere output token type, this is actually, instead of int, this should actually be enum toke tag. But I'm not gonna, I'm just gonna leave it as int, and I think we'll be okay. Okay, and then I want to, so let's commit that change. Use enum to define token tags. Okay, and I want to add a couple more tokens that I forgot, token types that I forgot. So in symbols, I need token arrow. So this is going to be like that thing for dereferencing a pointer and accessing a field in a struct. And I also need token dot, which is just the period for field access. And then down here with struct, I also want to add enum and union as potential keywords. Okay, so arrow dot I'm also going to need like plus plus. So I might as well do that now. Token plus plus. So I've decided that I don't want to implement like plus and minus because then I have to deal with like operator precedence and getting all that stuff working. So I have a trick for how I'm going to deal with like plus and minus and times because I am actually using at least plus and minus somewhere in here. Oh, I guess I also need like logical operators and relational operators. So I am using plus, and down here I'm also using minus. I'm actually going to extract these into library functions in like a header file that all programs will just like pull in, and then I'll turn these into function calls eventually, just so that I don't have to deal with like operator precedence, because I do not want to deal with that. So plus plus token equal token not equal token let's see, not equal and token, or are there any other? I think I also need not, so like token bang. Okay, so this is kind of a lot of extra things I'm adding. Am I using greater than anywhere? Yes, I'm using it there. Am I using less than anywhere? I don't think so. Token greater than. All right. ampersand, or, bang, and greater than. I like how that lines up. That's nice. Okay. All right. Let's go and implement these. I need to do enum and union. Let's do those first so I don't forget about them. So we go down to lex, and where are the keywords being defined? Struct. This should be pretty simple. Yank, paste, paste. We just need enum, and union, oops, token union. Okay, so those should be implemented. Now we need to do dot arrow. We need to do all of these. I already have comma. Dot arrow and plus plus. Can I open split to the right? Here we go. Let's go down here. Where are we defining these? I think I've reordered these. I just like to keep them in the same order. Okay. Yank. Okay. We want dot. We want arrow. Plus plus. Oops. Equal. And this actually needs to go before equal. Toke equal, not equal. So let's move this up above equal. Kind of weird ordering here. Arrow plus plus not equal. Ampersand, and or come in.
Hey, streaming?
Yeah. Not. Oh, and this needs to come after not equals because it's a subsequence of it. Not. And greater than. GT. It's not, it's bang. Okay. So now, just like to space these out. Okay. All right. Might be a good idea to commit this now. Another thing I was thinking about doing is building a table of all the names here so that I can, like, I don't have to look up the numbers. I don't know. It'd be really nice if I didn't have to, like, memorize these numbers. Because honestly, I'm probably not going to be able to figure out these numbers anymore, even. Oh well. All right. Let's check that this still compiles. Yes, that's my test over from the, I should make this bigger. This is a test from the parsing code over here. Okay. Yeah, why not? I think this will actually be pretty easy. So I'm going to copy all of this. Go right below here. We're going to make a character pointer array, an array of character pointers. And this is going to be called toke tag names. And we're going to paste all of this in. Okay, so now I need to go in and put quotes around all of these. There's some quotes. Quote, 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 quote. A whole bunch of quotes. And importantly, these are in the same order as the enum is declared. Is there a better way to do this? Wait. Ugh. No. If I go here, go down, and then I go find comma. It only does it for the first one. All right. This is like a VS Code Vim extension bug or something. I don't know. Or else I just don't know Vim very well. So we're just putting a whole bunch of these static string arrays, character arrays, static strings in a block of memory so that the names are accessible during runtime. Okay. Whoa, why are those all indented? There we go. Okay. So now, token pound should be in the same should be at index this, because I'm pretty sure this is just the integer 0. This is 1, 2, 3, 4, 5, 6. So it should be at index 6 of this array, token tag names. So I can make a function called debug token tag, which I want to take in a file stream, a file pointer, call it out, and a int token tag. And we're going to basically just look it up in that array. So we need to do fprintf s. Oh, and I believe I need to import this. I don't think it's. I was using that over in this file. Yeah, so stdio includes both of these. So yank this stdio. Okay, fprintf. So this takes the file, so out, and then the format string, token colon %s, and then toke tag names, toke tag, and return the result of this. So fprintf returns an int, which is like a status code. So we're just going to return that. Okay, so now I can go down here to my little test program, and instead of this, we're going to say debug token tag. The out file will be standard out, and the token tag will be out toke type. Okay, and I'm just not going to worry about that. Debug token tag, standard out token type. Well, in fact, I might as well just put this up here, and then I can get rid of the else case as well. But I suppose I ought to printf %n or /n at the end of this. Okay. So test lexer is my test program. So let's go in here. We're going to call this not main. We're going to say int main is test lexer. And then I should be able to run this. All right, cool. Yeah, so it's printing out all the file types. Pretty neat. Or all of the token types. I don't like these tab characters at all. Maybe instead of that, instead of tab, we should have like new line and then tab. non-void function does not return a value. Where? Oh. Yeah, whatever. Yeah, okay, so this looks like it's working. Let's just check the last line here. Char star meister. Where's meister? Meister. Char star ident meister equals literal string, and the literal string, semicolon, close brace, end of input. Yep, cool. All right. So what we've done, and I would like to commit these changes. What we've done is use enum for token type, add extra tokens, add debug printing for tokens. Okay. Sync the changes. All right, so I think now we are done with the lexer. And we're going to move on to the parser. Okay. So let me show you what we have so far. Currently, it is capable of parsing numbers and characters, character literals, number literals and character literals. And basically, these are very simple functions. Sorry, parse literal int and parse literal char are very simple functions. They just call lex, the lexer, on some input, and they give some new output, or some new input. They advance the input, and that's reflected in this out parameter here. So they get the next token, and they record the token type and the token value if there was one. Then this is parsing a literal int from the token stream. We check that there was a result. So if this is false, then that means we're at the end of the input, end of file. We check that there was a result and that the token type is token literal int. And if that's not the case, then we break out early, return false, and say, hey, this parse failed. And if not, we allocate one of these AST nodes, which we'll look at in 1 second, and fill in the tag, which is AST literal int, so that's different from token literal int. And we fill in the value. So we call a to I, which is converts a string to an integer on the token that we get, and we store that int value in value of this thing, and then return true. So what is AST node? Let's go look at that. So I've defined AST tag up here, which is just an enum, and then I'm doing the same thing we did over there in Lex. We have the names recorded in case we need access to those. Inside AST node, there's a tag enum. AST tag is a tag field. And then the next field is called as. And I'll show you why I called it as, just it's kind of a stupid reason, but I'm going to go with it. And it's a union between a whole bunch of different types of structs. So this is the struct It's sort of an anonymous struct value type, and the field name is literal int, and over here is literal char. So if you access one of these values, like my AST node dot as is the name of this union field, and then say literal int, it will interpret, whatever this union is as a literal int thing, and then you get access to the integer value here. So this value is the int value. If you were to say char here, then we would go into here, and in this case, we're storing the char data as a string. So this value, even though the names are the same, the value here would be a character pointer. So the reason we're using a character pointer, a string, instead of just a char is that character literals in C could be more than one character long. So like the backslash character, is backslash or /n. That's actually 2 characters long. And I don't want to have to convert between like the C representation and the ASCII representation of \n. So \n is 2 characters, 2 ASCII characters, whereas the actual new line character in ASCII is only 1 ASCII character, obviously. So I'm just going to keep it as a string. Okay. So I believe if I run this right now, yeah, we're just doing a test down here. We're just testing that things work. We're printing out, I should show you this function as well, which is a debug function. So it's very similar. We're switching on the tag of the node, given a pointer to an AST node. Switch on the tag and then print out, according to what data is inside of these things. And I'm calling this debug AST node. It might actually be good to, yeah, I think this would be good. Maybe what we should just do is like print out the tag type. So fprintfs to out format string will just be %s, and then we'll look up AST tag names of node arrow tag. And maybe after this we do like a colon space. Okay, so now if I try this again, yeah, that's actually nice. So for debug purposes, it'll say what we're actually looking at here. Okay. Improve debug debug AST node with more info. Okay, so let's just keep going. I'm going to build. Let's do AST literal string. So these are the easy ones. AST literal string. We need to add a variant to the enum, or to the union. So this is also going to be a character array. Okay. We need to add a case down here. It's going to be very similar to char. AST literal string, AST literal string dot value, and we want to display it with double quotes. Okay. parse literal int, parse literal char. Let's just copy and paste. Actually, let's not, because since you didn't get to see me write this, it'd be good to rewrite it. So bool parse literal string. We need a char pointer input. We need a char pointer out, or an out parameter new input. And we need a struct ast node pointer, since it's an out parameter, called node. Okay, so the first thing we do is, let me close this. First thing we need to do is call lex. So let's try this. We need to provide the input. We need to provide an out token type. So this is an out parameter. Toke type, which is really toke tag. I should be calling it that instead. And I need to make that, so int toke tag. Next, we need a character pointer out token, so token, a char pointer token, and these are going to be uninitialized, which is fine. And new input, and it returns a Boolean result, and then we need to check the result if result, yes,
Sorry.
If result is good and token tag is token, we're looking for literal string, then do something, otherwise return false. Oh, right, this is not a pointer, so I don't need to do that. Token tag is just an int, yeah, okay. So we've successfully, parsed. We were trying to parse a literal string, and we found one in the lexing, from the lexer stream. So we're going to need to malloc a new ast node. So I'm going to say star node equals malloc size of star node. So if you're not familiar with this, malloc allocates dynamic memory, and you need to tell it how many bytes you want. So size of is a built-in operator, which actually I think I need to add to the lexer because we're not detecting that, and it's not a function call. And if I say star node, that's actually, I could just as easily say struct ast node, and I'll say what's the size of struct ast node. I'll give you that many bytes. But there's a, I don't know, perhaps a bad feature of C where you can, even though this is uninitialized, it doesn't really matter. It doesn't actually, look at the data here because there's nothing there. It just looks at the type, and then at compile time it replaces this with, the size of struct ast node. So, okay, and then I know that I have to do this because I've written this before, but we're going to say, all right, set the tag to ast literal string, and set, we're going to say as literal string dot value equals the pointer to the token, the pointer to the 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 token that was parsed, which should be the contents of the string. Okay, and then we're going to say return true. All right, so that's how I was originally writing this. I mean, this really isn't that bad. It's very similar to what I wrote up here, except I broke this out and did like negation of stuff. Honestly, I kind of like this better. I don't know. I don't know which one I like better. I like having that separate, that's for sure. So the question is, do I want to check that result is true and this thing is equal, or do I want to check for the negation of that? And there's like De Morgan's law or whatever, and then return false early. That way this can be all in line. I guess I like this. I like this a lot better. All right. Or this is not equal, then return false. Okay. Take literal string, take literal string, take literal char. Okay. All right, let's test this. Backslash char, or double quote. And then print it out. Let's test it out. Whoa, what? AST literal string. Yeah, that looks good to me. Okay. All right, let's keep going. If I go to lex.h, let's just see what all we have over here. In terms of literals, we've done int char string. We should probably do angle bracket file name. So that is this token up here. These are all going to be pretty similar. So AST angle bracket file name. Honestly, maybe I don't need to do this, because this is not something that's going to be evaluated or anything. It's not like part of an expression. It only appears in like right after include. So I think I'm going to skip this one. All right. It's a token, but it's not necessarily like an AST node. All right. So, all right, what's next? Arrow, again, these are all like sort of punctuation things. They're not like expressions, although they can be used to form expressions. So these sort of are used to mark expressions. Keywords. So keywords. Let's do something simple. Let's do the well, true and false. Those are literals. So let's do those next. AST bool literal bool. So this is a little different from AST literal bool. This is a little different from the lexer, but that's okay. I want all my literals sort of together because they're going to be treated very similarly. So struct bool value, and the name of this will be literal bool. Okay. Then we add a case down here. It's going to be very similar to int. Ink, paste. literal bool. Let's do %s, and I'm going to do literal bool dot value. And let's use a ternary operator. I do not want to use a ternary operator because I will have to add it to the language, which means it's going to need its own AST node because everything I write here needs to be parsed by the language and understood by the language. I just don't want to do it. So we're going to do an if statement. If this is true, else. If this is true, then we're going to print true. Otherwise, we're going to print false. Okay. So that's how you print out a Boolean. All right. So let's copy all of this for parsing to parse a literal bool. We're going to get the token back. What form will the token come in? I think it's a keyword, so I think it will just, I think it's not going to have anything. For true and false, yeah, I'm pretty sure this out token, sorry, yeah, for keywords, there's no like identifier that we send back with it. So true is just going to be just the token type. That's it. So we're going to say if it's not, I think in this case I do actually want to invert the if. So we want to say if result is true and token tag is equal to true, then I don't know, maybe I think this is going to be awkward, but whatever. Or token tag is equal to token false. Then in here we're going to say if token tag equals token true. We can move this above here. We can say, okay, we're going to allocate a node, and we know that the AST type is going to be literal bool. And then all we have to do is assign the value. So if it's true, we're going to say the value of this bool is true. And otherwise, the value is false. Okay. And then return true. Oh, and if you get all, yeah, then return true. If this condition is false, meaning we got the wrong token or we're at the end of the stream, then return false. Yeah. Okay. Let's test it out. link, paste, literal bool, true, and false. Why am I doing it like this? This is so... We're gonna delete all these. Yes, I know we should be checking, you know, the integer number that comes out of fprintf. Whatever. We're just gonna do this. Okay. Let's test it. Literal bool true and false. Okay, cool. Let's keep going. Maybe I should push all this stuff, commit all this stuff. So implement literal parse literal bools. Okay. And we'll push those up to the repository. I will put the link to the repository in the description so that anyone who's interested can look at the code. And why don't I put that in the chat right now? So if I go to GitHub, and where are my repositories? Your repositories, Parasitic C, copy, and we're gonna go here to the chat. How do I, I'm not allowed to send something in chat? Okay, this is bizarre. Let me close this real quick and go to YouTube. And we're going to go here to the chat. I will paste this in the chat. I'm not allowed to send something in chat. Okay, this is bizarre. Can I edit video and throw this in the description as well? Description. GitHub repo. Okay. Save changes. Close that. And display capture again. And we'll go back here. All right. So what should we do next? Let's look at Lex. So that was a good test. We sort of had two branches we had to go down. Let's do the pound include. Let's do pound include. So I'm going to add something. Let's call this literals. Let's make this section, I don't know, directives or top level items. AST pound include. And then we'll throw this in here, put some quotes around it. Okay. Pound include. Struct pound include. So what does it need to know? Really all it needs to know is it needs to have a character pointer a string which points to the file name that is going to be included. So, for instance, here, it also needs to know if it's an angle bracket one or if it's a double quote one. Okay. If it's an angle bracket thing or a double quote thing. Okay. So, interesting. Am I allowed to declare enums inline? So there's the file name and the kind, which could be enum. Let's see if this works. I've never tried this and see. Angle bracket pound include or double quote pound include. Does that work? I think it does. Yeah, I've never really done much with these like anonymous types inside, like nested anonymous types. Like this is a very complicated thing, but I don't know, just data modeling. So okay, so now I've got a way to distinguish between these. Yeah, that's kind of nice. All right. So let's teach it how to debug print one of these case. And you know what? Honestly, this should just be called like display. We should move this out of here. Int debug ast node file pointer out struct ast node pointer node. Paste that in here and then call display. Return ast node out node, right? That way I can just print out, like this is the C code representation of each of these. Identifier default is undefined. What's going on? Identifier default is undefined. What? Case ast pound include. Okay. So how do we print one of these out? Well, we're going to do fprintf underscore s. The s, I believe, is like a safer version. So I have the docs open up here. Fprintf s since C11, so it's more updated than fprintf, which is C99. And if you read about it, the difference is it has a couple extra safety checks. So the following errors are detected at runtime and call the currently installed constraint handler function. I don't know what %n specifier is. If any of the arguments corresponding to %s are null pointers, it'll throw an error, which is nice. Stream or format or buffer is null pointer, it'll throw an error. Encoding errors in the strings. So I guess if you have like invalid Unicode or something, I'm not entirely sure about that one, but anyway, it just seems like a better function to be using. So that's why I'm using it instead of fprintf. Okay, so print out. The format specifier is going to be pound include, and then, okay, depending on, let's print that and print a space. And then we need to go if node.as pound, node is a pointer. Node as pound include dot kind equals angle bracket pound include, then we need to do one thing. We need to fprintf s out. If it's angle brackets, then we put the angle brackets here. And then we do node as pound include dot file name and return that. Return. Okay. Else, I'm just going to assume that there's only two kinds here. Angle bracket pound include return fprintf underscore s to out double quotes and %s node as pound include file name. Okay. So we should be able to print these out. Print out a pound include directive. Okay, what is going on with this? Identifier default is undefined. I don't know what that means. Does this still compile? Unexpected expression, something is funky. Implicit declaration of function display AST node. Okay. Well, this needs to be below this. That's fine. And then somehow I've messed up the case statement here. Is it like break? No, I'm returning stuff, so I don't need break. I think maybe I need braces around this. Because there are statements inside of these. I don't understand. Case. What am I not seeing here? Switch on the nodes tag. And we've got a whole bunch of cases. And I'm missing a semicolon somewhere. Return. Got semicolons at the ends of these. fprintf. This should be fine. Case default. I don't understand what's going on. Do I need... Ugh. This is the end of the switch block. Oh my god, what is going on? Is it not case default? Is it just default? Oh. Okay. Somehow I added a case there. That's weird. I don't think I need these. Right? Let's test. Yeah. Okay. All right, so we know how to print out a pound include expression, or a statement. Parse literal bool. All right. Let's close this window. Yank the top half of this function. Parse pound include. Pound include. Okay. So if the result is false or the token tag is not equal to, right, so we need this. We're actually going to lex three things. So we need, first we need a pound, token pound, return false. Next, we need boolean result. I think this should be up at the top. Do it again. And here we need this to go into, this is weird. Yeah, new input, but then down here we need this to be new input. So maybe, I'm just trying to think of like a good way to do this. We should do star. And here at the very beginning, we should say star new input equals input. So this is like old input. And the new input is like the one we're going to be advancing throughout here. Okay. I just want to keep this very consistent so I can copy and paste without making too many errors. Okay, so now we need include. And then we're going to do this again. And we're going to expect one of two things. I'm going to switch to and equals. Either you get, not include, but token angle bracket file name, or you get token tag, token literal string. Else return false. I don't know, maybe this should just be a statement at the bottom, because we're going to return true. Return true. Okay, and then in here we need to distinguish between these two, just like in the Boolean case. So we're going to say if token tag equals token angle bracket file name, else, and up here we're going to malloc, so we're going to say node equals malloc, the size of star node. We're going to set nodes tag to be ast pound include, and then we're gonna check between these two. So if it's angle bracket file name, then we're going to in fact, we could already set up here, we could say node as pound include dot file name equals token, right? So token is the thing we got out. You know. Okay, and then down here we just need to set kind is equal to angle bracket pound include versus down here it needs to be double quote pound include. Okay. Can I get rid of these? Okay. Let's test it out. Ink, paste, pound include stio.h. And we're also going to do, oh, and these should be parse pound include, parse pound include. This one we want double quotes. Okay, let's try running our tests. AST pound include stio.h, stio.h, yeah. So that's interesting. I have a sort of sub-classification. I mean, yeah, that's fine. Okay. Yeah, and the parsing works. So maybe I should be testing, like, if this is not the right thing, it's going to skip the last one. Yeah, okay. Let's include. What? Huh? Oh, these are, warnings. Ugh. Right, these are warnings, which I don't care about. I know I should be using, like, all W error, but it was just giving me annoying warnings, so I decided to not go with it. And it wasn't detecting the warning that I wanted, or the thing that I wanted. So what I wanted it to detect was up here in this printing stuff. Let me show you. So in printing an int, I had accidentally done %s here instead of %d. So value is an integer, and I need to output, to the format string, I needed to output an integer, but I accidentally copy and pasted, and this was %d or %s instead of %d, and it just like, let me actually run the program. I think it's like undefined behavior or something. It just like doesn't print anything. Yeah, see, it like crashes. And when I ran it with all W error, it did not catch that. It was still complaining about like, oh, unused variable, unused variable. So I'm like, all right, well, if you're only going to warn me about the stupid things and not the important things like this one, well, I don't want to use you then. So, anyway, if somebody knows how to tell the compiler to warn me about that stuff, I would appreciate that, because I'm not sure at this point. Okay. Well, let's see. What did we change here? We just did AST pound include. So let's commit this. Parse pound include. Sync changes. All right, this is good. We're sort of working our way up to the more complicated expression types or statement types, from the smallest to the largest. So next, let's think about what we should do next. I could do like expressions. I think if I try to do like a function declaration, I would want a way to parse sequences of statements. So I think I should leave that for last, just so that I can test all my code immediately. So I think what I'd like to do is maybe work on expressions next, or maybe types. Maybe types would be simple. Yeah, let's do types. Okay, so AST nodes. I wonder if types should be their own, like, if like I should just do AST type like that, and then have kind of a like a further nesting in here. I think that's probably a good idea. We'll have and then AST type. So for instance, type int. I guess I'll keep it flat up here, and then that way I can like reuse these. No, they should be like internal. This is weird. I'll keep it like this. Okay, and then down here. Oh, I need to add this here to our tag names. And down here, is that apple juice?
No, it's cream soda.
And gin.
I was going to do water and gin, and then I said, don't do that.
Yeah. Well, actually, I mean, I think that's the advice for like whiskey. If the whiskey's too strong, just like put more ice in till it's watered down to like the point where you can actually enjoy a drink.
Yeah.
I think I've heard that.
How many cups is the standard drink again?
Standard
or
drink.
fluid ounces. Here we go. 2 fluid ounces of 40%, right?
Standard drink. 12 ounces of regular beer.
1.5
What?
ounces of distilled spirits.
Yeah, 1.5 ounces.
You're still streaming that.
Yeah, so everyone just heard about your drinking habits.
Oh, that's fine.
Your very responsible drinking habits, I'll point out. Okay,
had, visitors? Have you had many visitors?
No, only Iran Cap. I can't even read a Russian. It's in Cyrillic. Look, this is the spamming I'm talking about. Oh, see, someone just like came on the stream and then left and spammed vor space dot ngo. Like, this doesn't make any sense. What are these spam bots? Whatever.
So are you recording this then?
Yeah.
And it's kind of like on your YouTube?
Right. So the nice thing is, like, whenever you stream to YouTube, it just automatically records.
That is nice.
I don't know, by default, I haven't, like, fiddled with any settings. So then I don't even need to save it on my computer. Like, I don't have to have the giant video file on my computer either. Which, yeah, so I appreciate that. Okay. I'm going to call it tie. So I can't type. Wait, can I? Can I have a field called type? Can I have an int called type equals 1? Oh, I can, because type is not a keyword in C. Oh, okay, nice. Okay, so type, we're going to have type tag, which is an enum. A type could be tie int, it could be tie bool, tie not string, char, tie ptr. I think that's all I support right now. I guess I should also do tie array. Oh, and also like struct. Oh god. Struct. Tie enum. Oh god. Tie union.
Okay. So are you still trying to do what C++ is doing? You're not doing your own thing still?
Do you know how intelligent what you just said was? Because yeah, I am kind of doing what C++ did, which is reinvent C from the inside out.
Right. Well, that's what you said you were doing.
Did I compare it to C++ out loud?
Yeah, you were like, I'm just trying to rewrite C++ and get the fire going.
No, rewrite C.
Oh.
Whatever. But that's correct.
I'll take it.
Nice.
But so you're not designing your own language, you're still trying to like...
Yeah, I am not yet designing my own language. I'm designing a subset of C right now. I get to cut out the parts of C that I want. But I kind of...
And so you're like only cutting out the parts you need because you don't want to have to do everything.
Yeah.
And so you are sort of making decisions about what your language will be like just by like what you can omit.
Yeah. Lying by omission, except it's language design by omission. There you go. Just like photography, it's all about what's not in the frame.
Yeah. I mean, yeah.
Okay. So type tag, and then I guess I need another union. This is a union inside of a union. Heh. Yeah.
Sorry, poked your butt. Your chair.
As again? Okay. I'm gonna just keep calling unions as. Okay, so if it's like one of these atomic types, like int, bool, char, then they don't need anything else inside of them. These are all compound types, though. So you can't have just a pointer. You have to have a pointer to... Oh, we also need void. Time void. You have to have like a pointer to void, a pointer to char, a pointer to bool. So these are all compound types. God, this is so complicated. So for int, bool, character, and void, I don't really need a union variant. Don't really need a union variant. So I guess I'm just going to leave it out. So the first one I'm going to do, let's say compound types, atomic types. Another approach I could take is just keep this as simple as possible for now and add features incrementally. Int not implemented. Not yet implemented. How about that? All right, so we will get to this. Or I could just comment this out and go bam. All right, so let's just work on the atomic types first. Atomic types. Okay. So we need a way to display types. Case ast type. Let's do another switch on node as type dot type tag tie int fprintf s to out int return There's going to be a whole bunch of these. Int bool char and void. Char. Okay, so that's the atomic types. So we can print those out. Now we need to parse them. Parse pound include. Bool parse type. I would like to copy this signature and the prologue up here, and the way that we lex things. Yeah, and this. So I think I'm making this a little more verbose than it needs to be because I want to keep things consistent. All right, so if result and token tag equals token int actually, let's just say not result, return false. And then let's do a case, or a switch. Switch on token tag. Can I have the default as well? Switch token tag. So in the case that it is token int, yeah. We need to allocate the node. Star node equals malloc size of star node. Star node tag equals AST type. So this is an AST node that represents a type. Honestly, this would be like better if we broke these into like multiple types instead of trying to keep everything as like a node. It's like you should not be allowed to have like we're gonna get into expressions with like plus. We're not gonna use plus, but like and the two things on either side of the and should not just be general AST nodes. They should be something more specific than that. They should be like Boolean expressions, you know, or expressions or something like this. So maybe I'm kind of doing this wrong. Maybe AST node is actually more of, yeah, okay. This is a problem. So we should not have a pound include right next to literal bool, literal string. Those should be like separate things. So this should be in the expression variant type. And this should be in like statements or top like items. Okay. All right. Okay, so we need struct expr. All right. It's going to have an enum. I'm just going to make it an anonymous enum. Expr literal int. Expr literal char. Expr literal string. Expr literal bool. Okay, those are our literals. This is called tag. Next, we're going to have enum, or a union, called as, where we have all four of these structs. And I'm going to cut and paste them over there. Okay. This is the expr struct. Yeah, this really is like very similar. This layout, which is a struct with an enum tag, and then a union with like structs down here. I mean, that's like a verbose, but like actually, it's like a valid way of doing algebraic data types, just like in Rust. So, okay. And I'm gonna get rid of these. I don't know how we're gonna do these. Let's just not worry about printing out the name of the thing. Okay. Struct item. So these are going to be, this is using the Rust definition of an item, where it's like a top level declaration or compiler directive. I think that's not actually like the real definition of an item in Rust, but it's close enough. Okay. So we need an enum called tag. And this could be a item pound include. And then we have our union component called, I'm going to call it as, to be consistent. And in here, we will cut this over. Struct pound include. So the reason this is a union is because we're going to be adding more things down here. So eventually there will be struct like function decl, but we're not there yet. We're just, this is the only item we're defining. Okay. And also, to be consistent here, pound include angle brackets. Pound include double quotes. Okay, so it has a file name and a kind. Yeah, okay. So that's top level items. Now we have types. So instead of this, we will have a struct called type. We'll have the tag, which could be either I'm trying to keep the naming consistent. Some of these atomic types, and then there will be compound types contain data, so they will there'll have to be a union down here for those. Okay. All right, we've royally screwed up all of the code we've written so far. That's okay. Our data is modeled a lot better. Okay, so display AST node, we should probably have like separate functions for display type, display item, and display expression. And there's also eventually going to be a statement in here. And you know what, I think I'd like to move struct type above, just below expression. So we go from like smallest to largest. So smallest element is sort of an expression, and then you get a, I don't know, I guess it's sort of the same size as like type. And then we'll have statements, struct stmt, enum, tag, union, as, I will comment these out, and I guess I need to comment all of these out. Okay, so once we get around to statements, we'll be doing stuff here. Okay. All right, so let's do display expression, expr, expr. Expr. Okay. Expr.tag, expr literal int, expr as literal int dot value. Okay. Expr literal char, expr as literal char, expr literal string, expr as literal string dot value, expr literal bool, expr as literal bool.value. Okay. And then this needs to be moved. Both of these need to be moved to a separate function. Int display next is going to be type. File pointer out, struct type, type pointer type. Switch on type.tag. All right, this is actually not what we want here, so this will go down here. Int display item, file pointer out, struct item pointer item, switch on item.tag. Okay, so this is now item pound include, this is item, this is item, and pound include angle brackets. Okay, let's fix this one, which we're still in the process of defining. I should probably be copying these default cases over. Type int, type bool, type char, type void. And this is called type. We just need tag. Okay. Invalid type tag. Invalid expert tag. And down here, display item case invalid item tag. Okay. I'm going to delete this function unless we'd like some super function that contains, no, there's no reason to like categorize all of these under the same thing. All right, so we're just going to delete that. Okay. So now parse expr literal int. Sure. This is going to be an expr. Oh, and this is nice. Because I was using this star node, size of star node down here for malloc. When I change the type up here, I don't have to change this, so that's nice. Okay. So this is expr literal int, I believe. And that's all I have to change. Nice. Maybe instead of node, I should call this expr to be a little more consistent. Expr, 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 expr. Okay, literal char, expr, 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 and then this becomes expr literal char. Expr, expr, expr literal string, and boolean expr, 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 this is tedious. Expr, anything else? Okay. Whew. So those are all the literals. I also want to change the names of these. Parse expr literal bool, parse expr literal string, parse expr literal char, parse expr literal int. Okay. Parse pound include, parse item pound include. This is changed to an item. I'd like to name this item. Pound include angle bracket or file name. This becomes item. Item. Same with this. Same with this. Same with this. Same with this and this. And this becomes pound include angle brackets, angle bracket file name. And this becomes pound include double quotes. AST pound include, this becomes item pound include. Okay. Parse type. I want to reorder this because I've been reordering everything. So this should come before the items. In fact, why don't we put like separators in here? Let me get like 80 characters. And then we'll do types. Exprs. And down here we'll do items. And above items, we should probably have statements. STMT statements to do. All right. So let's work on parse item pound include. So this is done. Parse item pound include. Parse type. Okay. Yeah, so this is where I was working. I'd like this to be type, called type. Instead of node, this is type. 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 Tag is type int. Oh, okay, this is weird. Sure, let's just assume All right, in the default case, all right, so in the default case of this switch, it means that the token tag, the lext token, does not correspond to anything that could be part of a type. In which case, we need to return false, but I'd like to allocate the memory for this ahead of time. And I could just not worry about leaking memory, but I think in this default case, I would rather just free star type and then return false. Okay. Where is free defined? Wouldn't it be nice if they knew where? Go to definition, go to references, go to type definition. That's not helpful at all. Where is free defined? Free CPP reference. This is in standard lib.h. Okay. Let's go all the way up. Standard lib.h. Free. Right alongside malloc. Okay. Now, where was I? Can include parse type. We were right here. Yes, we've just freed type, freed the allocated memory in case this did not work. I could just be repeating this line in each of the cases. I just feel like that's a little annoying, so I'd rather do it this way. And be careful and remember to free down here. So that's what we're going to do. Token int. Then the tag is going to be int, and that's all we need to record. So return true. If it is bool, then the type is bool. If it is char, then the type is char. If it is void, then the type is void. All right. Otherwise, we don't know how to parse it. We need to free this memory. All right, I'd like to check up on struct type. Yeah, so the only thing inside of type is the tag right now. I have these compound type tags and like plans for expansion with the union, but yeah, that's all we need right now. Okay. Cool, so that's actually finished. It's very basic, but that's okay. String parse type. I mean, maybe this should be called like parse atomic type. Parse atomic type. Okay. All right. I'm not sure why the type checker VS Code extension is not working. Let's restart C++ IntelliSense, because this should be throwing an error. This function no longer exists. This function no longer exists. Is that because I have an error up here? No. Oh well, I know how to update these. Parse literal int, parse expression literal int, and then display expression. Ast node is no longer a thing, so let's call this expr. Maybe these should be like separate functions. Void test expr, test parse expr. Expr. Parse literal int. Parse literal char. Display the expression. Parse literal bool true. And false. And we want the string. Backslash quote, backslash quote. Okay. All right. And then down in main, bool. Let's call test parse expression. Test void test parse item. Oops, we do want that. We want all of this stuff to go in here. And some setup. Item, 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 and item. What item? So these aren't like perfect tests, because really if this fails, it should be like else p error test failed, right? So we'll continue with the tests, but we'll just log that it failed. That's fine. 1 second. Okay, we're back. Test items and test parse items, test parse types, and test parse STMTS statements. So of course those don't exist yet. Test parse types and STMTS. All right. So to test types, we need input and type. I'm going to copy this down. Parse atomic type int type display type. All right, I think that should work. So int, bool, char, and void should all work. Implicit declaration of test parse item. Test parse items, test part item, test part items. Okay, I see. Implicit declaration of debug AST node. Here, display item and display item. Implicit declaration of parse pound include. Parse pound include, where is this? Inside of test items, parse pound include. So this should be parse item. No, hang on, where did I? Okay. And let's check that if I have bool test failed, no error. Yeah, okay. So that's a better testing framework in that case. All right. Honestly, this should probably be called test void test parser. And then we'll move all of this in here. And then tests finish running parser tests. Test parser. This should still work. Yes, all right. True, false, int, bool, char, void, yeah. All right, let's commit this because we made a lot of changes. Structure AST data types. Clean up tests. Implement parsing for atomic types. All right, and we'll push those changes. I think I'm going to stop this stream, take a break, and then I might be back, but it'll be in a separate video. So I'll start a new stream, you know, and then that way if people are watching through these, which they probably are not, in recorded form, then they'll have a video break here, and it won't be like a 7-hour video.